All right, let's take a closer look at question 5 of the grade 12 paper 2 of November 2022. All right, question 5.1 says, given that the square root of 13 sine x plus 3 equals 0, where x is between 90 degrees and 270 degrees, without using a calculator, determine the value of 5.1.1 sine of 360 degrees plus x. Now, we have to first of all construct a diagram here. We have to know, of course, in which quadrant this diagram is going to lie. I call it the red, so we're going to hunt for it quickly. We are looking where, if I just take what was given to us, we'll be given that the square root of 13 sine of x added with 3 equals to 0. That means we are looking where sine of x is equals to negative 3 divided by the square root of 13. So this is the quadrant where sine is negative. And I think if you remember the cast diagram, this is all, no, that's the cos quadrant. This is the A quadrant. This is the sine quadrant, and this is the tangent quadrant. Tangent would be negative in quadrant 3 and quadrant 4. So we're expecting our diagram to either lie in quad 3 or quad 4 because that's where sine is negative. And then after that, we look at the second condition that says our angle lies between 90 degrees and 270. So if 90 degrees is the angle here and 270 is the angle here, that implies our angle is either in quadrant 2 or quadrant 3. And I think you guys can see that quadrant 3 is the winning quad. So we're going to have a diagram drawn in the third quadrant. Okay, we're going to have a diagram drawn in the third quadrant. So let's have that quadrant quickly. There's my diagram there. I have beautiful looking right angle triangle. I need to feed it values. We need an x value. Remember, by definition, SOHCAHTOA, this is where my angle is located. That's the angle we're talking about. And then I think sine is the opposite side divided by the hypotenuse. So the hypotenuse will be root 13. The opposite side here will be 3. It has to be negative because of positioning and because we need a negative value when we divide 3 and root 13. We're missing the x value here, so we can quickly do Pythag to work out what x is going to be. And Pythag said x squared can be found by taking the difference between r squared and y squared. And then I think our r here is going to be 13 when you square it. Our y is negative 3 when you square it is going to give you 9. I'm getting an answer of 4. That means x is going to definitely be equal to plus or minus 2, but based on where it's located, I can clearly tell you that it's going to have to be negative 2. So first question says we have to work out what the sine of 360 plus x is going to be. I think if you just quickly use your reduction formulas, 360 plus is an angle that lies in quadrant 1. And in quad 1, sine is positive, so this will reduce to positive sine of x. And then I think we can then be able to say, oh, well, if we are looking for the numerical value of that, it will be negative 3 over the square root of 13. You didn't really need to have this red diagram that I have here to work out the solution to this, but generally when you are here, these kinds of diagrams assist a lot. Okay, so I've got that as negative 3 over the square root of 13. I'm moving on now to tan of x. Now, tan of x is asking us to figure out what the opposite and adjacent sides are, because based on SOHCAHTOA, we should all know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and the tangent is opposite divided by the adjacent side. So what's the opposite side here? Well, the opposite side in this context will be negative 3. I'm looking opposite as if I'm here. So opposite will be negative 3 and adjacent will be negative 2, and bingo, I'm ending up with 3 over 2. I'm expecting it to come out positive because the diagram is located in quadrant 3. And in quadrant 3, tangent is always positive. Okay, sweet. Now, moving right along to the next question. It's asking us to work out the cosine of 180 degrees plus x. Now 180 plus x, 180 lies here. 180 plus x drops us in quadrant 3. Cos is negative in quadrant 3. So this reduces to negative cosine of x by reduction. Okay, it's equivalent to negative cosine of x. Now once I've worked that out, I know cos by definition is the adjacent side divided by the hypotenuse. So I'm going to go back to my drawing. Okay, let's go back to the drawing and look at the adjacent side. It's negative 2 divided by the hypotenuse, which is root 13. So while I have negative 2 adjacent over hypotenuse, which is root 13, and I'm getting a solution that happens to be positive 2 divided by the square root of 13 as the numerical value to that particular reduction. Okay, 5.2. We're told here to determine the value of the following expression without using a calculator. Again, we're back to the reduction world. Remember, guys, every time when you've got 90, you always have to change your trig ratio to its core ratio. So I'm just going to make note of that. This 90 means change your ratio to core ratio. Okay, core ratio. The core ratio of cos is sine, and the core ratio of sine is cos. If you have these kinds of angles here, you have to add 360 degrees because it's negative 180. It's not looking good. We want it to be positive so that we can apply our ideas of reductions. Okay, so very important. Now, what does this reduce to? The cosine of 90 plus. In which quadrant does 90 plus lie? 90 degrees is clearly going to be on the vertical line here. So I've got 90 degrees here. And then 90 plus falls into this quadrant. Remember, all here are positive. Sine here is positive, tan is positive, and here cos is positive. So 90 plus drops into quadrant 2. And in quadrant 2, cosine is negative. So I'll say, oh, that's going to be a negative result. But negative what? Negative sine of theta, right? This negative, I am getting it from the fact that cosine in this region, okay, in this here quadrant where 90 plus theta is located, is going to come out negative. And then it just happens to change to its core ratio, which happens to be sine of theta. Now at the bottom here, I'm sitting with sine of theta minus 180. When you add 180, that's equivalent to just the sine of positive 180 degrees plus theta, okay, plus. Now, sine of negative theta, in which quadrant do you find negative acute angles? Remember, we start 0 degrees here, and when we count anti-clockwise, like 10, 20, 30, 40, all the way up to 90. That's the positive direction of counting our angles. Now, instead of going anti-clockwise, what if I went clockwise? Then I will be going in a negative direction. That means we can clearly say negative acute angles lie in the fourth quadrant. Like 20 degrees is in the first quadrant, but negative 20 will have to be in the fourth quadrant because you're going clockwise now, right? So it means here, this here that I'm looking at is quad 4, okay? That's in the fourth quad. And because it's in the fourth quad, I can clearly say, oh, well, that's going to simply be 3 times sine of theta, which is negative. So I'm going to have negative 3 sine of theta, because the 3 there is just multiplied to the sine. So if the sine becomes negative, I'm going to have negative 3 times the sine of theta. Okay, now let's reduce the last one. So I'm left with negative sine of theta here at the top. At the bottom, sine of 180 plus drops to quadrant number 3. And then quadrant 3, because 180 is here, when you're adding, it drops you into quadrant 3. And in that quadrant, only tan is positive and sine is negative. So I'm going to get negative sine of theta. And then I think from this one again, I'm getting negative 3 sine of theta. Okay, positive times negative is negative. And then you'll agree with me that we can add the numbers to the denominator to a single term. It's going to be negative 4 sine of theta. And one thing divided by 4 of itself gives you exactly a quarter. So that's going to be the answer there. 1 over 4 becomes the solution to that awesome question. Right, moving right along to the next one. 5.3 says we need to determine the general solution of the following equation. Determine the general solution. Okay, we want to solve, but we want to find a general solution for x. What angles will make this statement true? Now, I'm going to use the zero factor law because I can see that we've got a factor here multiplied by another factor equals 0. So if something is multiplied with something else and the answer comes out as 0, one of them has to be 0. Definitely, one of them has to be 0. And this is the principle we're using when we do a lot of our equations in paper 1. Okay, so what I'm going to say here is, okay, I'm expecting cos of x plus 2 times sine of x to be equal to 0, or at least 3 times sine of 2x minus 1 to be 0, because the product of these two things happens to be 0. So one of them must be equal to 0. So cos of x plus 2 sine of x is 0, or 3 sine 2x minus 1 will have to be 0. On the one that I have on the left hand side, I'm sitting with 2 sine of x is equals to a negative cosine of x. When I take away cosine on both sides of the equation, I've got 2 different trig ratios. I want to solve an equation. I'm going to divide by cosine so that I have only 1 and not 2. Okay, so when you divide by cosine, the left-hand side changes to tangent of x is equal to -1. And then when you divide by 2 on both sides, you're going to get -half. Okay, sweet. So it's going to be -half. So I'll say, oh, well, then tangent of x is -1/2. And then I can be able to, of course, continue to work out what the reference angle is going to be here. There's many different ideas that people engage when they get to these kinds of questions. It's up to you to decide whether you want to work the reference angle way, which is what I'm going to do here. I'll work out the reference angle of this as just the arctan of half, not -half. Arctan, let's write that down. +half. I know it's negative, but you work out the arctan of of +1/2 to work out what the equivalent angle is going to be. It happens to be 26.565, blah blah blah. And then of course we're then going to say, oh, we are looking for where the tangent is negative. Only now do you start using the negativity, this negative here. Only now you start considering this. You ignore it first and then you consider later. So what am I doing here? I'm looking for the quadrants where tangent is negative. So tangent will be negative in which quadrants? I think it's going to be quad 2, and then another one is going to be in quadrant 4. That's where tangent is negative. That means one of my answers is coming from quadrant 2, and that's where x is going to be 180 minus what you are sitting with there. All right, that's going to be 100, and let me write 180 degrees minus the reference angle 26.565 plus k times 180 to make it general, because it happens every 180 degrees. Okay, then you're getting 153.43 degrees plus k times 180 degrees. That's the answer we're getting from quadrant number 2. So from quadrant number 4, x is going to be 360 minus the reference angle 26.565 blah 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 plus k times 180. Again, you always use 180 for tangent, but you lose 360 for sine and cosine. So I'm ending up with 333.43 degrees plus k times 180 degrees. And somebody's asking, what is this k? Well, k is an element of integers. Okay, k is an element of integers. We only solved 1/2 of the question. Let's go back and try the other one. Okay, the other one here, we have to add 1 on both sides. So I'm going to have the sine of 2x is 1/2. Not 1/2, but 1/3 when you divide both sides by 3. So we're looking where this graph is equals to 1/3. I think, again, we need the reference angle here. Okay, do not divide by 2 now. Please don't do that. Work out the reference angle. We're going to get 19.47. 1 degrees, and then after that we check the quadrants where sine is positive. So where is sine positive? Sine is positive in quad 1 and also in quad 2. In quad 1, the reference angle becomes an answer because 19 degrees lies in quadrant 1. Therefore, we will say 2x is 19.471 plus k times 360 to make it general. Okay, this is the answer that I'm getting from quad 1. Answer from quad 1, right? Now, once you've done that, you'll then see that you've got a 2 there that you need to divide by. You've got a 2 that you need to divide by, and when you divide by 2, your answer comes out as 9.74 degrees, and your 360 changes and it becomes 180 because you're dividing every single term by 2. Okay? Or, where's our second answer going to come from? After quad 1, we're going to check what's going on in quadrant 2. And I think in quadrant 2, you have to say 180 minus to get the answer, just like we did with the tangent. So that means your angle x will be 180 minus, not x, but 2x. Remember, we were working with 2x here. That angle is what makes it to the calculations of quadrants. So 180 minus the reference angle, which was 19.471, plus k times 360 degrees to make it general. Of course, you have to divide all the terms by 2 after subtracting 19 from 180 degrees. You then end up with an answer that says x is exactly 80.26 plus k times 180 degrees. And somebody's asking, what is k? Well, we already mentioned that k is the element of integers. So that's how you will work out this particular question that involves working out the general solution of a trig equation. 5.4 says, given the identity cos of x plus y multiplied by cos of x minus y equals to 1 minus sin squared x minus sin squared y, we want you to, first of all, in 5.4.1, prove the identity. Now, when you are proving the identity, remember, you're sitting with two sides. This is regarded as the left-hand side, okay? And this here is regarded as the right-hand side. Now, you can't mix them up, okay? Don't add anything on both sides. Don't subtract anything on both sides. You have to work out one side independently, and the answer should look like the other one. You can pick any of the two sides. So I want to pick this one because it looks like there's a lot of things we can do. So I'll say the left-hand side is equal to. So I'm sitting with cos of x plus y. I'm going to expand it. What is the expansion of cos of x plus y? Somebody might want to see that nicer. So let's just first of all start by copying it down. So I'm looking at the cos of x plus y, all right? And then I'm going to multiply this with the cosine of x minus y, okay? So the first one, the first expansion here, the yellow expansion, cos of x plus y, cos expands to cos. I'm using compound angles. It's going to be cos of x, cos of y. If it's a plus, you change to a minus. It's going to be sine of x multiplied by sine of y. This information is always available to matrix in the information sheet. Now for the green one, cos of x minus y, I'm going to just expand that as well. I'll get cos. You get cos of x, cos of y. If it's a negative, you change it to a positive sine of x times sine of y. Okay, I've got what now? I've got a binomial times a binomial. It's like a minus b times a plus c. I don't know about you, but this looks like the product that leads to difference of two squares. And because we want to always make sure that we take advantage of these opportunities when they present themselves. Look at this, cos x cos y, sin x sin y, cos x cos y, sin x sin y. It's the same thing in both brackets and the same thing in both brackets. One has a minus and the other one has a plus. So it's like if I had a minus b, and then in the other one I have the same characters, a and b as well, but the sign is now plus. And we know that this is what will multiply to difference of two squares. It's going to be the first one squared minus the second one squared. If you don't see that, there's no shame in going the long way, this by this, and this by that, and then this by this, and then this by that. You're going to get a long string of terms, and then some of them will cancel, of course, leading you to just the difference of two squares. So we're going to take advantage of that. Let's go. It's going to be the first one times the first one, which is the first one squared. So if you square that, you get cos square x times cos square y minus, and then if you do the same thing for these ones, you're going to get sine square x, not minus, but times sine square y. Okay, so this is what we're ending up with, right? Now, the expression we're trying to prove on the right-hand side has no x's. I mean, no cos's. The only thing we're having on the right-hand side, this is just y and x in terms of sine, or sine in terms of x and y. There's only sine and sine and sine and sine everywhere. So it means that on what I'm working with, I need to get rid of the cos's. So I'm going to use the identity, you know, the squares identity. What does the squares identity say? It says to us sine squared plus cos squared is 1. I think we all know that, right? I'm going to take advantage of that. Sine squared theta plus cos squared theta is 1. That implies that I can change all my cos's and call them 1 minus sine squared theta. Okay, I'm taking advantage of that, right? Because what I'm trying to prove has no cos on it. Okay, so let's see what will happen. Okay, cool. So I will change the first one, right? Let's change it and see what will happen when we do that. I will have 1 minus sine squared x times 1 minus sine squared y. Okay, that's what it is. That's what cos squared is. It's 1 minus sine squared. And then the signs are fine. You guys are fine. We need you. Times sine squared y. And then after that, we're going to do this product now. 1 times 1 is 1. 1 times sine squared is going to be sine squared y. Sine squared times 1 is going to be another sine squared y. And the negative times negative is going to be positive sine to the power 4 of y minus sine squared times sine squared is sine to the power, oh no, I can't actually get that. Okay, yeah, quickly, let's fix that. It's not going to be sine to the power 4. One has got x and another one has got y. So let's try and fix that quickly, otherwise this whole thing is not going to work out. Right, yes, let's get that line again. We've got x's and y's. So be careful, it's easy to make a mistake. So 1 and 1 is 1, right? 1 and sine squared y is sine squared y. Sine squared x and 1. You see, there's x and y, that's different. Okay, sine squared of x, and then negative and negative is going to give us a positive product, but it's going to be sine squared x multiplied by sine squared y. They can't simplify to sine to the power 4 because one has got x and the other one has got y. So let's bring back everything else that we had. We had sine squared x times sine squared y as well. So that's pretty awesome. And what do you notice here? We notice that the last two are the same. So they will cancel each other. They'll subtract to literally a 0. And then that literally leaves us with the stuff that we have on the left-hand side, which is 1 minus sine squared y minus sine squared x. And then, beautiful people, we can then say, oh, we have finally arrived at the end. The left-hand side is equal to the right-hand side, which is what they wanted us to prove. Okay. Now, the next question is asking us to do the following. They say, hence, we know when we see the word hence, it means use the previous result. Okay, use the previous result. Okay, use the previous result. Okay, hence determine the value of 1 minus sine squared 45 degrees minus sine squared 15 degrees without using a calculator. Now, what you see here looks like what we have on the right-hand side of this original equation we were given there. Those two left-hand side and right-hand side equations. They gave it to us as 1 minus, okay, sine squared x minus sine squared y. It's exactly what we just proved now. 1 minus sine squared x minus sine squared y. But in this case, if you look closely, since the structure is exactly the same, I think you guys will agree with me, the x in this case will have to be 45 and the y is 15. By comparison, if you look closely, the position occupied by x is the position occupied by 45 degrees. So x equals to 45 degrees, and for y's, the position occupied by y here is occupied by 15. So y is equals to 15 degrees. Okay, so I want to take this x value and y value and sub them on the left-hand side of the original expression. Remember, we said the left-hand side is cos x plus y and cos x minus y. So cos x plus y, cos x minus y. So I'll say that here equals to the other left-hand side part. So 1 minus sine squared x minus sine squared y equals to cos x, was it x plus y? I think it was cos x plus y, and then cos x minus y after, according to what was given to us, the original expression. It was cos x plus y, and then times cos of x minus y. Okay, so if it's the relationship is that way in terms of x and y, it means that the 1 minus sine squared 45 minus sine squared 15 degrees, okay, is the same as cos of, we said x is 45, 45 plus 15 times the cosine of 45 minus 15. Okay, and allow me to finish it off here because we're running out of space now. So the cos of 45 plus 15 is the same as the cosine of 60 degrees times the cosine of 45 take away 15 is the same as the cosine of 30 degrees. These are special angles. Cos 60 is a half. Cos 30 is root 3 over 2. So I'm getting root 3 over 4 as my final answer in this particular question. I don't know if everything went well, but this is actually how you would compute this as root 3 over 4. Important for you to compare what you've done with what you're trying to do now. So it's clear that x is 45 and y is 15 based on the fact that the structures of these two questions look exactly the same. Quickly, moving right along, 5.5 here says, consider the geometric expression 16 sine x times cos cubed of x minus 8 sine x times cos of x. 5.1 says, rewrite the expression as a single trigonometric ratio. A single trig ratio. All right. So if you look at what we have on the left-hand side here, 16 sine x cos x cubed, and the second term here, 8 sine x cos x. Let's look at what is common. What is common, first of all, is that 8 is common in both of them. So I'm going to take out 8 as a common factor in those two terms. The second thing that is common is they both have sine of x. So I'm going to take it out. I'm just factorizing here. Take out sine of x as a common factor. And then there's also cos of x that is common. So I'm also taking out cos of x as a common factor. When I do that, what does it leave? It leaves us a 2, because 8 times 2 is going to give you 16. The sine is out. I've got 2 cos's left because I had 3. So now I'm going to be left with 2. And then in the second term, 8 is out, sine of x is out, even cos of x is out. That means that leaves us with just the 1. Okay, now this is equals to, now on the left hand side, look at it closely. That sine of x multiplied by cos of x looks almost the same as the structure for a double angle of sine, except that the double angle of sine uses sine with a 2, not an 8. So I'm going to split my 8 to 4 times 2 sine x cos x. And I hope you guys will appreciate the fact that sine x cos x with the 2 is going to be a double angle of sine. So 4 times 2 still takes us back to 8 sine x cos x. And then on the terms that I have inside the brackets, it's 2 cos squared x minus 1. That's the double angle of cos. That's literally going to be cos of 2x. Okay, that's what I'm getting from the brackets inside. Now my 4 still stays there. So what I have here becomes just sine of 2x when you're reversing the expansion of a double angle, and this one is cosine of 2x. Again, this still takes the structure of 2 sine of a cosine of a. That also looks the same as those ones there, where my a in this case happens to be 2x. So we know that that has to be sine 2 times that. It has to be sine 2 times the area. Okay, so very, very important. So I'm going to do sine 2 times whatever I'm looking at there. Okay, very important. So from the 4, I'll have to have a 2, okay, times the 2 sine of 2x cos of 2x, which is where my double angle is going to come from. I'll have 2. So that inside there, okay, becomes sine double the angle that is repeating, okay, that 2x that you see. If you double that, you get 4x. And then this becomes 2 sine of 4x. And it's not very complicated. It sounds like a very simple and straightforward thing to work with. As long as you understand what the expansion of a double angle looks like, we end up with 2 times sine of 4x as our answer. Now in closing, for which values of x in the interval between 0 and 90 degrees will this 16 sine x times cos cubed of x minus 8 sine of x times cos of x have its minimum value? Minimum value. Okay, now if you're doing trig and you have your trig expression represented by a single trig ratio, you can think about it in terms of graphs, okay? Now let's do this. Graphically, if I'm thinking about it as a graph, what does that mean? If I think about it as a graph, let's just say maybe the graph of y is 2 sine of 4x. What would it look like? Let's just draw it because they want it between 0 and 90 degrees. What will that sinusoidal graph look? It's a sine graph. What will it look like? It will look exactly like this. It's a sine graph. This is how sine graphs look. It's important for you to know them because you can literally use them whenever there's a need. So the highest value it will get to will be 2, and the lowest value it will get to will be -2. And this is because of the amplitude. I can see the amplitude of the graph is going to be 2. It's this number right over there. Okay, it's going to be 2. Now, what will be my x values here? Usually you have 90, 180, 270, and 360, but this is not going to be the interval for this particular graph. This number here dictates what the x values are going to be, the critical x values on the graph, okay? So if you want to work out the interval, you always have to say, okay, let's first of all get the period of the graph. The period of this graph will be 360 degrees divided by that number you see there, which is 4. And if you take 360 degrees, you divide it by 4, you should get 90, okay? We're going to get 90. And when you take 90 and you divide it by 4, it will give you the interval or the scale, okay, or the values which this particular graph keeps moving by from one x value to the next critical x value. So the interval is going to be the 90 degrees that I have divided by 4. So 90 degrees divided by 4 literally gives you the number 22.5 degrees, okay? 22.5 degrees. It means each one of those x values that you see there, where interesting things happen. Like here, it's 0. This one here is going to be 22.5 degrees. And then the next one here, when you add 22.5, is going to be obviously 45 degrees. And then if you add another one, is going to literally give you 67.5 degrees. And then lastly, when you add another one, it's going to give you 90 degrees, because we're supposed to see the full graph in 90 degrees, since we said the period of the graph is going to be 90 degrees. Now the examiner is asking you, of course you could have arrived at the answer much faster, but it's important for value, okay? We want you to get value out of this. They want you to work out the minimum value of this thing. Where is it smallest? It's going to be smallest here, okay? And they don't want the actual value. The actual value is clearly -2. That's what the minimum value is going to be. But they're asking you for which x value. At what x value is this going to happen? So you'll say when x equals 67.5 degrees, we're going to have a minimum value on this graph, and that minimum value is going to be equal to -2. But they just wanted the x value, so you'll give them that 67.5. So that is how you can analyze these trig questions. Thank you very much.